So we will continue our discussion on language modeling. In the last lecture, we defined what do we mean by language models, and we have looked into particular example of n-gram models, which is inspired from or which takes the Markov assumptions, and then we saw that how to estimate those parameters. So in today's lecture, we will also discuss that why we have used the stop symbol, and then we will see that what are the issues with the n-gram model and how we can take care by something called the smoothing techniques. So if you remember that when we discuss trigram model or the bigram models, we have said that we assume that we have, of course, this is a vocabulary, which is the set of your tokens, as well as we have specific symbols which indicate the end of the sentence. If we don't, then what happens is that we have to do is that we have to consider we have to take into account the variable length of the sentences. So if we don't have this stop symbol, then what will happen is that we have to assume that my sentences are of length n, and this n is also a random variable. So either we have to sort of bring one additional random variable which sort of takes care of this variable length, or we use this stop symbol, and then that automatically takes care of the variable length of sentences. So that is why we use variable that is why we use the stop symbol. I hope this idea is clear. Now just to recap that what we have discussed regarding these n-gram models, so this is just an example of the trigram model. Accordingly, you can think of bigram models and so on, or if you want to look into the 4-gram models or the 5-gram models. So only thing will change is your the parameter and how you estimate those parameters. I mean, the formula will almost remain the same. You have to adjust accordingly. So you have this finite set of the vocabulary. You have set of the string, which basically that you essentially says a set of sentences where each of these xi's belongs to this vocabulary and v, and the last word in the each of the sentence or the string is basically the stop symbol, or I mean sometimes it's for example, if you remember in the last class I was indicating with some symbol like this. So you can, just to say that this stop or this any kind of a specific symbol just to indicate that the end of the sentence. And then only parameter here is these probabilities. Okay, pw given the two last the previous two words, such that this w is coming from v vocabulary union the stop, and uv is coming from v union star. So in fact, let me adjust. Yeah, so that is now fine. And then we have estimated this probability p with the maximum likelihood estimation, and now we denote that as a p hat ml. So this hat, whenever we use the hat ml, that sort of indicates that this is an estimation, and actual probability without it is written without hat. So that's kind of a standard notation. And ML, I have just to sort of emphasize that this is a maximum likelihood estimate. You will understand that why I am using this subscript later on in today's lecture. So this is the maximum likelihood estimate, just which is based on the frequencies. And if you have the bigram, then it accordingly you have these parameters would be written, but more or less this components remains the same. Okay, so here I have given so okay, in this particular thing I have forgot to put the hat. So these are the hat. So this is unigram model, this is a bigram model, and then you have this trigram model. So now what is the problem with the MLE, this maximum likelihood estimate? So this works well if your test corpus is very similar to training, and all the words which you are going to see in the test cases, or all the bigrams or the trigrams possible which you are seeing in the test corpus is already has been seen in training data, then it works quite okay. But we know that that is generally not the case, simply because that it's no matter how big your corpus is, you can assume that if you have, again, just to sort of think in case of this trigram model, so you can just think that if your vocabulary size is of the order of 20k, then the number of parameters which you have to estimate here in case of the trigram model is of the order of VQ, and so that is approximately how much it would be, that many parameters which you have to sort of estimate, and so then you can understand that these many parameters, these many combinations of the words could be possible, and then you really have to have very large corpus to really sort of make sure that you can perhaps see all of these combinations, which will not happen. So as we have also discussed in the last class, that we have these sparsity issues, and there are two kind of a problem, that if you see there are some words which has not occurred, if it is a if you are doing this kind of an account, or if you are having these unigram models, then at least if you have not seen, you can take care of with using this unknown category. But then if you are looking at the counts with respect to that, you are looking at the count of the bigram or the trigrams, and then it might happen that you will have either the denominator or the numerator being 0, and that will sort of kind of in one case, when the denominator becomes 0, then it's undefined, and when the numerator becomes 0, then it's kind of an underestimating those probabilities. So what we can do about it? So for that we are going to discuss the smoothing techniques.